Okay, we're solving problems with fractions in this question. Okay? In this one, we have equivalent fractions on both sides of the equal sign. Okay? In other words, these are equivalent ratios. So I'm going to go about solving this two different ways, and you guys use whatever way you feel most confident with. Okay. They're both technically the same, just they look a little different. So x plus 2 over 3 equals k minus 4 over 5. Okay, we're just going to rewrite it here quickly. And then in our second example, the exact same question, just a little different. Okay, in our first one, what I want you guys to recognize is both of these are division signs, right? So, in order to move a number, we need to multiply. Okay? So what we can do here is to move this 3 over, we would have to multiply by what value? 3, that's right, because this says divided by 3. Okay? So if I move the 3 over, this now becomes multiplied by 3. And the 3 on the bottom is eliminated. So we have k plus 2 is equal to k minus 4 over 5 times 3. Okay? And if you're stuck and you're not sure what to do here, you can distribute. Another thing we can do is we can move the 5 over. Because technically, once I distribute, this 3 is only going to affect the numbers on top, and this is still all going to be over 5. So instead of distributing right away, the next thing I might want to do is move this 5 over. Okay? And in order to move the 5 over, what operation do we have to use? Multiplication. That's right. This will become multiplied by 5, and this 5 will disappear. So before we do any distributing, this will then say 5 times k plus 2 is equal to k minus 4 times 3. And it doesn't matter if the number's at the back or the front when we're using distributive property. Okay? So, I broke this into two major steps. We could do this very quickly. You could just bring the 3 over to the one side and the 5 over to the other, which is also commonly known as cross-multiplying. Okay? These are technically just steps to it. From here, we got to expand. So when we expand this number, 5 times k, and 5 times 2. And we'll also do 3 times k and 3 times negative 4. Okay. So we do the first one. What is 5 times k?
5k.
Good. And 5 times 2? 10. Great. We still have the equal sign. 3 times k? 3k. 3 times negative 4? Negative 12. Excellent. Now we want to get all of our like terms together so that we can simplify. My like terms here are 5k and 3k. 10 and 12. I should use a different color for that. So, in this case, I'm just going to move the variables to the left side, and I'll move the constants to the right. So I'm going to do this all in one step. So hopefully you guys can kind of follow along with this. The 5k is going to stay. I'm going to write it again in black here. 5k. When I move the 3k over, what does it become? Negative, because we're moving the entire function. Many of you guys get confused. If I wanted to separate the 3 from the k, I'd have to divide by 3. But if I'm moving the whole term as 1, because it's positive, it becomes negative on this side. Okay? We'll do that in red. Negative 3k is equal to, I'm going to leave the negative 12. And when I move 10 over to the other side, what does it become? Negative 10. Excellent. So now our like terms are all together. 5k minus 3k? 2k. Negative 12 minus 10? Very good. Negative 22. Now we want to separate the 2 from the k. That's right. Because it's multiplication, we need to divide when it goes over. So when we divide, we have k is equal to negative 22 over 2. What is k equal to then? Negative 11. Excellent. So I did that one way. Another way we could have done this. It's okay. So we're going to do this the other way now. Another way we could have gone about doing this is actually making both of the denominators the exact same. In other words, a common denominator. And we'll talk about why that could help. What would be a common denominator between 3 and 5? 15. Great. So in order to turn both fractions into 15, we have to multiply them by a specific number. So in order to turn 3 into 15, what do we got to multiply? 5. So whatever we do to the top of a fraction, we do to the bottom, same idea. So we multiply top by 5 and the bottom by 5. What about to turn 5 into 15? By 3. Good. Whatever we do to the top, and we do the bottom. Okay? So our denominators will be 15 on both sides. I want you guys to see this. And before I go farther here, I'm going to leave this 5 on the outside so you guys see the similarity. So it's 5, and it still has to be multiplied by k plus 2 and k minus 4 still has to be multiplied by this 3. I haven't distributed it yet. Okay? Now, if the denominators are the same, if they're equal, okay, what we can do is multiply the entire equation by 15. Whatever you do to one side, you do to the other. And this process technically eliminates both denominators. So you can think of it like this. Once I get the denominators the same, okay, I can essentially drop them. Okay? So, now that I've dropped them, you don't have to do this little process I've done here. Technically, I multiply both by, I'll show you what I'm doing. I multiply both by 15 again, so we're adding another number. 15 divided by 15 is 1, so they cancel out. But the idea that I want you to understand, so you don't have to do the proof, is that once the denominators are the same, we have equivalent fractions, we can drop them and just work with the numerators. So now that we do this, it is 5 times k plus 2 is equal to k minus 4 times 3. And the reason I did it this way is, do you guys see a similarity here?
Yes.
What do you see? They're the exact same. We're now at the exact same point when we were here as we are here. We just had different processes from the right and the left. Whatever you find more comfortable is fine. From here, I'm not even going to continue the rest of the work because we've already solved it. The rest of the work is down here on this page. Okay? Just the first part of eliminating the fractions, whichever way you find most comfortable is best. And I think most of you will probably remember this cross-multiplying more than you'll remember this process. Okay? But choose what you like most.